Hey everyone, and welcome back for another deep dive.
Glad to be here.
Today we're traveling to the Orion Nebula.
Ooh, exciting.
Yeah, and we're going to be looking at this paper published last month.
Oh, wow. So fresh off the press.
Yeah, in the Astrophysical Journal
Okay.
about the discovery of protoplanetary disks.
Protoplanetary disk.
Yeah, you know, those swirling clouds of gas and dust.
Yeah, the birthplaces of planets.
Exactly. And get this,
What?
they're around brown dwarfs.
Brown dwarfs.
Yeah, brown dwarfs.
Wow. That's pretty unexpected.
I know, right?
Yeah, what's going on there?
Well, it's a discovery that's been decades in the making, actually.
Really?
You might remember back in the 90s.
Way back then.
The Hubble Space Telescope captured these really intriguing images
Oh, yeah.
of proplyds in the Orion Nebula.
Okay, I remember that.
And scientists at the time suspected
Yeah.
that some of them might be around brown dwarfs. But they didn't have the technology to confirm it back
No,
then.
of course, yeah.
But now,
With the James Webb Space Telescope
JWST.
and its incredible infrared capabilities,
Yeah.
we have definitive proof.
Wow.
That's pretty amazing.
That's really cool.
So this really flips our understanding of planet formation on its head.
Oh, yeah, absolutely.
We always thought about planets forming around stars like our sun.
Right, the big ones.
Yeah, but now we see that even these much smaller and cooler objects
Can host their own planetary systems.
Yeah, so let's talk about brown dwarfs for a minute.
Okay.
So these failed stars
Yeah.
that never quite got big enough
To ignite.
to ignite hydrogen fusion.
Like our sun.
Like our sun, right?
They're kind of the underdogs of the cosmos
Yeah, they are.
because they lack that mass to kickstart that fusion process.
Right.
Brown dwarfs are way cooler than stars.
Yeah.
And they emit energy primarily in the infrared spectrum.
And that's why the James Webb Telescope was so crucial for this discovery.
Right, with its infrared superpowers.
Exactly. And speaking of size, you won't believe how small some of these brown dwarfs are.
Oh, really? How small are we talking?
The smallest ones in this study are only about 5 times the mass of Jupiter.
Wow, that's tiny for something that could have been a star.
Right. It's a mere 0.5% the mass of our sun.
Wow, that's incredible.
Just imagine a star that tiny
Where?
with its own disk of planet-forming material.
That's wild. It really changes how we think about these things.
It does. And the Orion Nebula itself
Oh, yeah.
is just this giant stellar nursery.
A bustling hub of star formation.
It's teeming with newborn stars.
How many are we talking?
About 2,000 of them.
2,000.
Yeah, and it's about 1,300 light years away from us.
Which is actually pretty close.
Yeah, in cosmic terms.
That's our backyard, practically.
Exactly, and tucked away among all those newborn stars,
Yeah.
we now find these brown dwarfs.
Adding a whole new layer of complexity to this already amazing cosmic landscape.
It's so cool.
Yeah, it really is.
It makes you wonder
Well,
what kind of planets could form in these environments.
Yeah, I mean, with the brown dwarf emitting so much less energy and heat,
Right.
I mean, would these planets even be remotely similar to the ones we see in our own solar system?
Yeah, it's a question that scientists are really eager to answer.
I bet.
Because the brown dwarf's lower temperature
Yeah.
would definitely influence the composition and characteristics of its planets.
Right. Like, what would they even be made of?
Yeah, and think about it.
Yeah.
A planet huddled close to its dim, cool brown dwarf sun.
Trying to stay warm enough for liquid water.
Right, the habitable zone around a brown dwarf.
Yeah.
It's much smaller and closer in than around a star like our sun.
So these planets would be in a constant balancing act.
Wouldn't they?
Yeah.
Not too close to be scorched,
Right.
but not too far to freeze over.
Yeah, like Goldilocks.
Exactly, and remember we talked about those planets
Yeah.
being tidally locked to their brown dwarf?
One side always facing the brown dwarf?
Right, and the other side always in darkness.
Yeah. That would create some crazy temperature differences across the planet's surface.
And probably some pretty wild weather patterns, too.
Oh, definitely.
It's amazing to think about the kind of adaptations life would need to survive in those conditions.
It really is.
But here's where things get even more interesting.
Oh, really?
Remember those 2 proplyds that Hubble spotted decades ago?
The ones that kicked off this whole investigation.
Exactly. Well, it turns out they have a few more surprises up their sleeve.
Okay. I'm intrigued. Tell me more.
The light coming from those proplyds,
Yeah.
it doesn't quite match what astronomers expected.
Oh, that's interesting.
Yeah, it's like some of the light is being absorbed or scattered in a way that hints at something unexpected happening within those disks.
Like they're holding on to a secret.
Exactly. And to delve deeper into that mystery,
Ooh, yes.
you'll have to join us for part 2 of our deep dive.
Can't wait. Welcome back to the deep dive.
We're still talking about brown dwarfs.
Yeah, it's incredible to think that just a few decades ago we weren't even sure if brown dwarfs could even host protoplanetary disks.
Right.
But now we're uncovering their secrets.
Thanks to the James Webb Space Telescope.
JWST.
It's really amazing.
It really is how quickly our understanding of the universe is changing.
Before we delve deeper into those secrets, though,
Yeah.
I think it's worth taking a moment to appreciate
What?
how different these planets around brown dwarfs might be
Okay.
from the ones we're used to in our own solar system.
Absolutely.
Yeah.
One of the biggest differences would have to be their composition. Remember, brown dwarfs don't have enough mass
Yeah.
to ignite hydrogen fusion.
They're kind of duds,
Yeah. So they're mostly made up of lighter elements like hydrogen and helium,
right?
which means the protoplanetary disks around them
Yeah.
would also be richer in those lighter elements.
Okay.
So that would affect the planets forming within those disks.
So instead of rocky planets like Earth,
Yeah.
we might find more gas giants like Jupiter.
Maybe even more massive with thicker atmospheres.
Oh.
It's a real possibility.
And it's not just the size and composition.
Right. The brown dwarf's lower temperature would also play a role.
Big role. Yeah. Imagine a planet
Huddled up close to its dim, cool sun,
trying to stay warm.
desperate for that warmth so liquid water can exist.
The habitable zone around a brown dwarf is much smaller
And closer in,
than around a star like our sun.
these planets would be in a constant balancing act.
Right.
Not too close to get scorched,
But not too far to freeze.
like Goldilocks.
Not too hot, not too cold.
Just right.
And remember those planets being tidally locked to their brown dwarf?
One side always facing the dwarf,
The other side always in darkness.
creating dramatic temperature differences across a planet's surface.
And some really extreme weather patterns.
Oh, yeah, for sure.
But how do we even detect them?
Well, that's the challenge, isn't it?
Yeah.
I mean, the traditional methods like the transit method,
Right, where we look for dips in a star's brightness.
when a planet passes in front,
That's much harder with the brown dwarf.
much harder.
Because they're so faint.
But there are other techniques.
Yeah. Like what?
Gravitational microlensing
Okay.
might be more sensitive to planets around brown dwarfs.
So we might not be able to directly image them,
Not yet, at least.
but we can still find them.
We can.
It's like a cosmic game of hide and seek.
It is. We have to rely on our ingenuity to find these hidden worlds.
And our technology.
That too.
Speaking of puzzles,
Oh, yeah.
let's go back to those mysterious proplyds.
The ones with those strange light signatures.
Yeah. What are some of the leading theories?
Well, there are a few intriguing possibilities.
Okay. I'm listening.
One theory suggests that there could be large clumps of dust
Dust.
or even rings of material within those protoplanetary disks.
Like miniature versions of Saturn's rings?
Yeah, but made of dust instead of ice.
That's a pretty cool image.
It is.
But those rings might be too small for us to see.
Too faint as well.
But their presence could explain the light patterns we're seeing.
That's right.
But there's another possibility, right?
Even more mind-bending.
Okay, lay it on me.
What if those protoplanetary disks aren't perfectly flat,
What?
like we usually picture them?
Warped or tilted disks.
Yeah.
But how is that even possible?
But some astronomers think those warps could be caused by
By what?
the gravitational influence of unseen companions,
Like another brown dwarf.
or even planets hidden within the disk,
Their gravity would tug and twist the disk.
creating those warps and tilts.
And that's what we're seeing in those light patterns.
Exactly.
So we have these brown dwarfs, potentially surrounded by rings of dust.
And maybe even harboring hidden planets.
And their disks are warped and tilted.
It's amazing.
That's mind-boggling.
It really is a testament to the incredible complexity of these systems.
And it reminds us that we're still just scratching the surface.
When it comes to understanding brown dwarfs and their potential to host planets,
Welcome back, everyone.
it's great to be back.
We're diving into the final part of our brown dwarf deep dive.
The grand finale.
And we left off talking about...
Those mysterious proplyds.
Yeah, remember those odd light patterns?
Astronomers are really digging into those signals.
It seems like there's definitely something unusual going on.
Yeah, within those protoplanetary disks.
So let's recap.
Okay.
We talked about a couple of intriguing possibilities.
Yeah, like those large clumps of dust.
Or even rings of material.
Miniature versions of Saturn's rings.
But made of dust instead of ice.
Exactly.
It's a pretty captivating image.
It is, isn't it?
But we also talked about
another theory.
The one where the disks themselves might not be perfectly flat.
Warped or tilted.
Which is a really cool concept.
But what could cause such a phenomenon?
Well, we talked about the possibility of unseen companions.
Lurking within those systems.
Another brown dwarf, or even planets.
Hidden within those disks.
Their gravity would be tugging and twisting the disk.
Creating those warps we're seeing in the light.
It's mind-blowing to think about.
It is. It really highlights how much we still don't know about brown dwarfs.
And their potential to host planets.
Thankfully, we have some incredibly smart people working on this.
So how do we go about confirming these theories?
It all comes down to data.
More data.
Exactly. Astronomers are already planning follow-up observations.
With the James Webb Space Telescope.
And other powerful instruments.
To try and get a clearer picture.
Of what's happening within those proplyds.
It's like putting them under a cosmic microscope.
And with those more detailed observations.
We'll be able to see if it's rings clumps or warped disks.
And maybe even find evidence of those hidden planets.
It's a cosmic detective story.
Unfolding right before our eyes.
We started this deep dive talking about brown dwarfs.
As these failed stars.
But I think it's safe to say
they're anything but failures.
They're dynamic.
And complex.
And they could be home to a whole new category of planet.
That challenge our very definition of what a planet can be.
They're a reminder that the universe is full of surprises.
And there's so much left to discover.
So keep looking up.
And keep exploring.
And that's it for our deep dive on brown dwarfs and protoplanetary disks.
Thanks for listening.
We'll see you next time.